Good morning, everyone, and once again, welcome to our lesson. And I wish to introduce topic number 7 of Pure Mathematics 3. Remember, we continue to explain what is in Pure Mathematics 3 in this video, and I would want to introduce a very important topic on page 146 called integration. And I would wish just to state the following, even before we look at example 1, that a function and its differential has been explained in topic number 6. For example, we have heard that if y is equal to the sine of x, then the differential of sine x is simply the cosine of x. I have outlined them, all of them here, all what we have discussed before. But of most importance, it is for me to say that this could be the forward movement and there is the backward movement, such that the integral of the cosine of x is now the sine of x, as illustrated here. The integration of the cosine of x is the sine of x, and obviously you remember that for any primary integration we add a constant, that means plus c. We have seen before that if y is equal to the cosine of x, then the dy dx is the negative of sine of x, and that means that we can also have a backward movement, whereby if we are dealing with the sine of x, the integration of the sine of x is now becoming the negative cosine of x plus a constant. Please note the negative reflect on both ends, and so on and so forth. And we will continue to use each one of these in our explanation. For now, let us just go straight to example 1. But before we go to example 1, we also have the function when we have y is equals to arc sine x, the dy dx is equals to 1 over the root of 1 minus x squared. This will be explained later at a later stage in this very topic. So don't worry, I have put nothing here. I have not put a reverse movement here. They'll be explained later in this video, in this topic, even as we move on. Right now, I want us to just go straight to example number 1, and we are told that to find the integral of 2 cosine of x plus 3 over x minus the root of x, everything with respect to x. And just like we have been differentiating polynomially, even integration, we need to learn how to integrate polynomially. That means a term at a time, meaning that if we take the first term, we're going to have the integral of 2 cosine x, which is now we can use the very first one. The integral of cosine x is sine x, of course, plus c. This means we are going to have 2 sine x plus c, and we are done with the first term. And let's go to the second term. Again, the integral of 3 over x dx. Please note x is at the denominator position. That means we will have to highlight our integral when x is at the denominator position, and this one is going to be advised by differential movement, which is forward movement. When y was ln x, then dy dx was 1 over x. So the integral of this must be natural logarithm of x. So let's see. So the integral of 3 over x is obviously going to be 3 natural logarithm of x, of course, plus a constant c. That's how we need to deal with that as a part of our integration. So the last part is we need to know how to do the integral of the root of x dx, which is easily the integral of x raised to power a half dx. And it goes without saying this is simply primary integration, whereby we have to add 1 at the index. A half plus 1 is obviously 3 over 2. So we are going to have x 3 over 2 over 3 over 2. That is going to be like that, plus a constant. But of course, when you remember what we do here, when we divide by a fraction is the same as multiplying by its reciprocal. So the whole thing at this level becomes x raised to power 3 over 2, and this constant now, this divisor now becomes 2 over 3. So when we divide by a fraction, it so means like we are going to multiply by its reciprocal, of course, plus a constant c. So it is our duty now to collect all these integrals and put them together. So we can simply talk about the integral of 2 cosine of x plus 3 over x minus the root of x with respect to x is going to be, all the signs will apply, unless where we have trigonometric integration where some signs can change. We have seen that the integral of sine x is negative cosine x, and we now need to combine all this, which is 2 sine x picking the first integral, 2 plus 3 ln x picking the second integral. Of course, because we had a minus here, it remains a minus 2 over 3 picking the whole of this, x 3 over 2 now at this point, plus a constant c, because all of them have been considered. So finally what we should write is that now the integral of this is 2 sine x plus 3 natural logarithm of x, natural logarithm of x minus 2 over 3 x raised to power 3 over 2 plus a constant. And that is as far as now the integral. Please note we have talked about integrating term after the other, that is polynomially, and we have been able to acquire it, and that is example 1. This is simply this is just example 1 and part A. So in our next video, I'm going to explain example 1, part B, and this would be awesome. So welcome once again to my YouTube channel, Pearson and Excel International A-Level Maths by Mr. Kamotho, and subscribe, like, and of course share, so that we continue to work together. All right.